Day 2 of chemical bonding. We're going to talk about some properties of ionic bonds. Ionic bonds are very strong. They're solids at room temperature. They have high melting points and also high boiling points. They're a metal and a non-metal. So what does that mean? That means in the periodic table, metal combined with a non-metal. They do not conduct electricity in the solid state, but they do in the liquid and aqueous states. What does aqueous means? It means it's dissolved in water. So let's do some examples of the formation of ionic compounds. You simply do the electron dot structure, so your Lewis structures, to predict the compound that would form between sodium and fluorine, for example. Sodium has one valence electron because it's found in group 1 or 1A on the periodic table. Fluorine has 7 valence electrons, which means it needs one electron to look like a noble gas, and sodium needs to lose one electron to fall back down to a noble gas formation. So when these two combine, when they form a bond, because fluorine is very electronegative and it's going to steal or grab onto that sodium poor little single valence electron. But when you write the formula, you first put down the metal, then you put down the non-metal. So this would be NaF, sodium fluoride. Let's do another. Let's do magnesium and chlorine. Do the same thing. Give me the electron dot structure for magnesium. And then for chlorine, magnesium needs to get rid of 2 electrons. Why? Because it's located in group 2A. It has 2 valence electrons in its outer energy level. Chlorine only needs 1 electron. So we're going to need 2 chlorines to bond with the magnesium. So this can form the most stable bond. Again, we will write the metal first and then write the non-metal. So this would be magnesium chloride, MgCl2. Let's try another. Aluminum and sulfur. Let's think about this. Aluminum is located in group 13. So that has 3 valence electrons. Sulfur is located in group 16. And it has 6 valence electrons. So we're going to need 3 sulfurs to combine with 2 aluminums. They're going to form a bond. There's aluminum with 3 valence electrons. There's the sulfur. This electron, if you follow the arrows, kind of going off the screen here and such, but this electron can go here. This electron can go there. This electron can go up here. This electron can go right there, and it leaves us 2 more electrons on this aluminum atom. This electron can go there, and this electron can bond here. Again, write the metal first. Yeah, aluminum 2, sulfur 3, also known as aluminum sulfide. So we talked about empirical formulas last time, but let's just recap. It's the chemical formula for an ionic compound when it's arranged in the smallest whole number ratio. It's basically the smallest amount of atoms possible to form the most stable bond. Example would be magnesium nitride. Mg3N2 is the empirical formula for magnesium nitride. Mg6N4 is not the empirical formula because it's not the lowest whole number ratio possible. And a joke. I have an extra one here for you. You can take it. It says sodium. Sodium's so nice. I only have 17 electrons. I feel so much better if I had one more. It says chlorine. Sodium's so nice. Hands over the electron. Chlorine says, wow, are you sure? Sodium says, yeah, I'm positive. And that's it.
You're here.